We will discuss about column store index usage as far as SQL Server is concerned in this demo. I'm going to use database AdventureWorks DW for this demo. I'll be creating a table called table2. Table2 will be getting its data from table fact product inventory, which is present in AdventureWorks DW. I'll be inserting the same data from fact product inventory to table2 twice after creating this particular table. Once this table is created, what we'll do is like we will create another table called table 3, and we will use a select star into for this table 3, and the data for this particular table will come from a fact product inventory table that is present in AdventureWorks DW database. We will enable the statistics time comma IO on, and then we will execute this particular select query, which basically selects table 3 dot movement data, comma sum of table 3 dot unit cost and average of table 3 dot unit balance. We will be inner joining table 2 and table 3, and we will have the join condition as product key equal to product key, that is basically like it is table 2 dot product key to equal to table 3 dot product key, and table 2 dot date key equal to table 3 dot date key, and we will group the results group by. We will use the group by of table 3 dot movement data, and then we will use the same column to order the results as well. So let's execute this query. So let's include the execution plan and execute this query one more time. And if I look at the execution plan, what I'm able to see is like we are scanning through table 3 and table 2. And if we look at the data, what I'm basically doing is like we are, as far as table 3 is concerned, we are scanning through all the records on that particular table. And also on table 2, we are basically scanning through all the records. So for table 3, we are scanning through 7,76,286 records. We are reading 776,000 records, and then we are returning 7,76,286 records. And as far as table 2 is concerned, we are estimating close to 2.3 million. We are reading close to 2.3 million and returning 2.3 million. And then the result set for both these tables basically gets joined by a hash match, and then we perform a group by, we do the aggregation and everything, and then it gets the result set gets sorted, and then we basically display that in the SSMS. And now if we look at the stats, what I'm able to see is like we are performing close to 115,000 logical reads in table 2, and close to 3,800 logical reads in table 3, and then there is a work table as well. So now what I'm going to do, I'm going to create an clustered column store index and on table 2, and then we will check the performance of the same query. So in this case, we are creating the cluster column store index. Since we have this aggregation there and the table size is also huge, we are going for column store index. Basically, like column store indexes are really, really good when the table is on the higher side as far as the rows are concerned. And also, we do a lot of aggregations. For this demo, I'm looking at this specific query, and I'm feeling like adding in cluster column store index is going to help. Let's try running that. What I'm seeing is like it just completed, and now looking at the execution plan, what I'm able to see is like on table 2, I'm able to see that there are close to 2.3 million records being read as far as table 2 is concerned. We are estimating 2.3 million, and then we are reading that much, and whatever we are returning is also some of it is same there. Now if you look at it here, what we are basically doing is like the estimated number of rows per execution for all execution is 2.3, and then actual number of rows is also like 2.3 million. So now we have an hash match. It is same as the last plan. The only difference is like we have a cluster column store index scan. Now looking at the stats, if I look at the stats, what I can see here is like, let's compare this with what we have done as far as the row store index is concerned. And now if I see, and it was before 11,000, and now we are doing close to like 6,000. So we have reduced it by 50%, or 10x, it is close to 50%. That's it for this video. Thanks for watching. Have a great day. Jai Hind.